Hi everyone, how are you? I hope you're having a good day today. Welcome to the joy of sets. In this video, we're going to look at some basic things about sets. We're going to look at equality, equivalency, and cardinality. But we do have some other videos about sets, and you can find a bit more detail in those. This video should stand on its own, however. First, we'll just remind ourselves, what is a set? A set is just a group of things, but it's a group of things that we deal with in a mathematical way. So here is a set, and this set is the set of all non-zero Arabic numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9. We've put them in braces to show that they are a set, and when we deal with sets in this mathematical way, sometimes we show them using a capital letter just to make it easy. In this case, this is set A. So now let's look at another set. This is the set B. We've shown it in braces again, and what can we see here? We can see that set B has exactly the same members as set A, all the numbers from 1 to 9. The only difference is the order they are in, but they have exactly the same members, and so we can say that set B is equal to set A. So just a quick question for you. Which of these sets is also equal to set A? Pause the video if you'd like to think about it, but I will tell you now that sets G and J are equal to set A. In this case, they all have exactly the same members, the numbers 1 to 9. So now we've looked at equal sets. What about this set? Here we have the set C. So, is this set equal to set A? Clearly, we can see it has different members. These are the even numbers that are less than 20. And so we would not say that the set C is equal to the set A. But we can see that there's the same number of things in that set. They have the same number of members. They have the same cardinality. When you have two sets that have the same cardinality, the same number of things in them, you can say they are equivalent to each other. So set C is equivalent to set A. Okay, in the last two slides, I've mentioned cardinality several times. I'd like you now to pause the video and just say out loud to yourself, what is cardinality? Have you done it? I hope you were able to do that, but please don't worry if not. If you're just learning about sets, cardinality is quite an abstract idea. It's a simple enough idea, but it's not something that we deal with in everyday life a lot, so it's something you can find slips away from you quite quickly. Cardinality is a number. It's the number of things in the set. It's not the things, it's not the set, it's just the number of things in the set, which we treat as a mathematical thing. We write cardinality by n brackets the name of the set that we are using. So in this case, the cardinality of set A is n brackets A. It takes a bit of getting used to, but cardinality is something that we use quite a lot when talking about qualities of sets. Let's go back to these sets now, and again let me ask this time, which of these sets are equivalent to set A? Pause the video if you'd like to think about it, but I can tell you that all of these sets are equivalent to set A. They all have the same number of members, so they all have the same cardinality. And the cardinality of these sets is 9. If we go back to looking at set A, there is another way we can write it. We can write set A like this. We still have the braces and we start off normally, but then we have an ellipsis in the center before going to the last few members. The ellipsis stands for members that we can easily predict from some pattern. If you know the first few Arabic numbers, 1, 2, 3, and you know that they end with 8 and 9, then you know what comes in the middle. So we can use the ellipsis to make it easier to write out large sets if we can predict their members from a pattern. I'd like to leave you with one last question. Given that we use the ellipsis in this way, what does that mean for this set, set Z? You can find the answer and much more about sets in our other set-related videos. They are a little bit older now, but I hope you can still learn something from them. And before I go, I'd like to show you one more set, and that is this set here. This is the set of all the people who are subscribed to this channel. There are now 1,000 people, and I know all YouTubers say this, but I am surprised and amazed that that many people have decided to subscribe at this point, even though I haven't put very much up here for the last few years. But still, thank you all for being subscribers, and if we're going to use the ellipsis trick, we could also show this set a little bit more easily like this. This is another way to write out the set of all subscribers to this channel, starting with subscriber number 1 and finishing with subscriber 1000. But if we look at this set here, a mathematician would say this is not a good way to show the set of subscribers to this channel. It's fine for a fun video like this, but although these excellent people are subscribers to this channel, we cannot use a pattern to easily work out who all the other excellent people are who have subscribed to this channel. So, at least according to a mathematician, this is not a good way of showing the set of all subscribers to this channel. However, no matter who you are, if you are a subscriber to this channel, thank you very much for watching. I hope you've enjoyed our videos, including this one on the joy of sets. If you'd like to, please drop a like or a comment on this video. I would love to hear what you think. And of course, you can also subscribe if you aren't already. But thank you for watching, and bye for now.